So we are going to today finish up, what did we do yesterday, last time? We did partial fractions, right? And the reason why we did partial fractions is so we knew that we were going to have to solve this equation. Okay, and we said in order to solve this equation, we're going to end up being dp, if I move this guy down here, kpn minus p is equal to, well, I'm not supposed to move the k, leave the k there, dt, right? And then this guy here is going to, we want this in a form that looks like that. Because now I can integrate this, right? We talked about being able to integrate this. I cannot integrate this, but I can do this because now I'm going to be natural log of something minus natural log of something. Okay, that's the whole reason of learning how to do the partial fractions, okay? So let's go ahead and we'll start right into an example. We'll go on page 373, tracking a moose population. In 1985 and 87, the Michigan Department of Natural Resources airlifted 61 moose from the Algonquin Park, Ontario, to Marquette County in the Upper Peninsula. It's originally hoped that the population P will reach a carrying capacity in about 25 years with a growth rate of, and the actual equation that is given to you is 0.0003.
I'm missing a zero.
Am I missing a zero?
Yeah.
Not anymore. And 1,000 minus p. Okay? So what do we know here? There's one thing that we do know right off the bat. What is it?
It can't be greater than 1,000.
1,000. 1,000 is the carrying capacity. Okay, this is the carrying capacity, so that we know that right off the bat, so that when we draw the logistic curve, it's going to go like this, and it's going to max out the carrying capacity at 1,000. Okay? All right. So, let's see if we can go ahead and actually work this out. I'm going to leave the k term here, put these two underneath, move the dt over. P is equal to 0.0003 dt. Okay? So again, I'm going to want to go ahead and make this into a partial fraction. So I want this guy that looks like this to look like something like that, right? So if I'm going to try to put this into this form, if I go ahead and do the common denominator, I'm going to get a 1,000 minus p plus bp. If I collect the p terms, what do I get from the top? Just the p's. I have, what do I have here? A times minus p, so I get minus a, right? Minus a, and I get what here? I get b, right? So in other words, I'm going to get b minus a p plus 1,000 a p1 minus p. Now this and this have to be the same. So I get b minus a is going to be equal to 0. 1,000 a is equal to 1. Did everyone understand that? Do we get that? Because I'm supposed to have no p terms up here, right? In other words, b minus a has to be 0. And if that's 0, what do I have left? I have 1 left, so that has to be 1, correct? So what do I get? I can immediately find out what A is. What is A? 1/1000th, right? And A is equal to B. So B is equal to 0.01 also. We good? All right. So in other words, I can say that this guy here is 0.001 P plus 0.001 1000 minus P dP 0.003, missing a zero again, dt. Okay? We good? Any questions so far? Take the integral of both sides. What do I get here now? Well, actually, let's go ahead and pull the this guy out. Make it look like that. Right? I can actually multiply both sides by 1,000, correct? And I should now get rid of that. Like that. So if I integrate with this, what do I get? Natural log of P, right? What do I get here?
The natural log of 1,000.
Natural log of
1,000.
is equal to what do I get here?
X. T.
T
Plus C.
plus C. Oops. Plus. Right? We good?
That'll work.
That'll work.
Yeah.
Okay, blah, 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 blah. So we're up to that point. Okay, so, wait a minute. Okay, so I'm missing here, this is supposed to be negative. Why is that supposed to be negative there?
It's what was 100 minus B?
Huh?
100 minus B would be the natural log of.
Isn't it supposed to start with minus
Where?
on the top?
On the top here? Oh, they started with minus here, is that what they did?
No, but
No,
I'm
it's plus.
confused. Why are we doing plus?
No, it's wrong.
Oh, I see what happened there, okay, so it's plus. So,
They didn't do any of that in the book.
Yeah,
they didn't do that book, they didn't do that part, they did, yeah, they did. They did that part.
Well, they did, but they didn't do it like you did.
So therefore they didn't do it.
Well, they did it differently.
So this is supposed to be minus here.
No.
No, I think it's
In the
supposed to be
book,
plus.
This is plus, right?
Yeah.
Yeah. Why
Okay,
is it
so
plus?
A minus A, B being the same,
Can we do?
BP, A 1,000 is 1. Yeah, we're good.
Can we do minus
Where?
like on the top?
What's up here? Do minus here? If I did minus, what happened here? Then this would be minus, correct? All that does is it changes what? Now this becomes minus, right?
But then you can run it back through and make it positive.
Yeah, so it ends up being the same thing. So then this would be, okay. So let's go back to having it plus. What do I get? A 1,000 minus A, oops, go back to plus, BP plus, this is equal to 0. You're going to say Okay, so we're good all there. We're good all the way there.
Yeah, they just want a couple steps.
And then, so they
Maybe
have
split it
exactly
all.
what I have, except they have a minus there.
100 minus P.
Oh, okay. There's a minus P here, correct?
Mm-hmm.
Okay,
Oh,
so
that's
that's why that minus comes here, right? Because if I take the derivative of this, what do I get?
-1.
If I take the derivative of this, I get 1 over 1,000 minus P. Then I have to take the derivative of this, correct?
Mm-hmm.
Yeah. Oh.
Right? So you see where the negative comes from there?
Oh. So the it'll multiply and cancel.
Yeah. So that's why that's negative. Okay? Alright.
Then how come when they switch it, it's not negative anymore?
So I'm here, right? We're good up to here?
Yeah.
We're good up to here? Okay. We'll start from here. So I'm going to get natural log of P over minus P is equal to 0.03 T plus C. Right? Log A minus log B is log A over B. Okay? E. What does this become? E to the C 0.3 T. Correct? We good?
How did you? Why did you do that?
Why did you put the C first? Or did you use C?
Doesn't matter.
No, I guess not.
It's the same, right? Doesn't matter, right? Okay? Alright. So, what am I trying to solve for here?
P.
I'm trying to solve for P, correct? So, how am I going to do that?
You move it to the other side. What? Oh, I don't like that.
Over P is equal to E to the C, E to the 0.03 T over 1.
Well, we can just move it to. Oh.
But one's
It's
equal to.
What happens here? The good thing is this. So this is what ends up happening. Over P minus 1, E to the negative C, E to the negative 0.3 T.
Are these guys absolute value?
The 1 moves over. Right? Are we good? You following so far? And this just becomes a constant, correct? So, I don't need this anymore. You're going to put this guy down underneath here and move the P up here. Is that okay?
Sure.
I thought I tried to solve for P.
We are. That's why I'm going to swap those. Correct? We follow?
Is that
So this looks familiar, doesn't it?
Yeah.
We talked about the logistic function, right? This looks familiar. So we just proved how to solve a logistic function. Okay? Yes, this is not easy. Okay? I will maybe have this on the test.
No.
Okay? Not sure. Okay? But this is basically what we learned earlier, right? This is what a logistic function looks like. The carrying capacity is on the top, right? What is the initial value here? What is the initial value of P? At time equals 0, right? My initial value of P is going to be equal to Oh, yeah, it's only 61, right? So this is going to be equal to 61, which means that A plus 1 is equal to 1,000 over 61. A is going to be equal to that. Right? Somebody do that for me, please.
It's
Anybody?
15.393.
What? What?
It says 15.393 in the book.
15.393. So my actual function is going to look like that, right? So this actually is my function. Okay. Questions that people like to ask here is, at what point does the function grow the fastest? Okay. What does a growth curve look like? Let's go back to the initial function now. The initial function was what? dp dt is equal to k p m minus p. So in this case, the k was what? 0.03, and p was, don't know what that is, 1,000 minus p, correct?
It was 0.0003.
So when does this function grow the fastest? When, because this is the growth rate, correct, by definition? dp dt, and it's the rate of growth, right? So, the rate of growth looks like this, which means that this is a function that looks like what? Right? When does it grow the fastest?
The top.
When is it the top?
500.
500. In other words, half the carrying capacity at that point is when the growth is the fastest. Does that make sense?
So is that like consistent?
Yeah, where any kind of logistic function, if I ask you, when does it grow the fastest? At what point, when P is, when at what population does it grow the fastest? It's half of the carrying capacity. So if you look at the growth curve, if you go back to the actual curve itself, right? That happens right here, right? What is this called? Point of inflection, right? Because we are going concave up to concave down, right? And when does that happen?
500 equals 0.
Double prime equals 0, correct? In other words, this is prime, right? So this, the growth rate of this, when this guy is equal to 0, right? And that happens right here, doesn't it? Right? Okay. Not easy. Not easy. Okay? And I am done with 7.5. We'll call it good. We'll call 7.5 good there. Go ahead and press the stop